module number 5. Number 5. Functions. We have functions. Define and contrast the two kinds of mapping, the one-to-one and on-to, and determine if functions are injective or surjective. We already know what is injective and surjective way back during our mathematics in the modern world. Mathematics in the modern world. Ready na, guys?
Yes, sir.
Yeah.
Yes, sir.
Let's proceed. Number 5. The one-to-one function. One-to-one function. Obviously, it is a relation that is an element of the first set related to only one element in the second set. Function or mapping may be denoted as x to r related to r, or simply y is equal to f of x. Where y, dito we can observe that x is our independent variable and y is our dependent variable. Some synonyms for the word mapping are map, function, correspondence, and transformations. Okay, so meaning to say we can read this as x maps to y, x functions y, x corresponds to y, or x transforms to y. So ito, we have an example of a one-to-one function. One-to-one function, where an element in the first set is related or is mapped or is corresponds or transforms to one and only one element in the second set. For example, 1 maps to 1, 2 maps to 3, 3 maps to 2. So this is a one-to-one function. Now, the relation define x maps y as given by the figure below, where the elements of x are 1, 2, and 3, and the elements of y are a, b. Is a function since no two images in y have the same pre-image in x. This also defines a function, because if we will be returning to the definition of a relation and a function, this particularly describes a many-to-one relation. Many-to-one relation. Right? Many-to-one relation. And still, many-to-one relation is a function. And furthermore, no two images in y have the same pre-image. No two images in y have the same pre-image. So let's recall then what are image and what are pre-images. When we say pre-image, just like if you are in front of the mirror, yung reflection na nakikita nyo sa mirror is said to be your image, right? I repeat, if you're in front of the mirror, the reflection that you can see as a surface of the mirror is your image. Meaning to say you are the pre-image. You are the pre-image. So the elements of x are said to be the pre-images. The elements of x are said to be the pre-images, and elements of y are our images. So no two images in y have the same pre-image. So hindi nag-share dalawang images in y sa isa pre-image in x. Therefore, this is a function. The relation defined by x maps to y as given by the figure below, where x is defined as 1 and 2 and y defined as a, b, and c is not a function. It's not a function since f of 1 is a, at the same time f of 1 is also b. So they actually two images shared a single pre-image. Two images A and B have the same pre-image. Ayan. This is one to many. If we define this in relation form, this is one to many. So one to one is a function, many to one is a function, but not the third one, many to one. Baliktad, one to many, I should say. One to one, many to one, and one to many. We have the three types of relations, and two of them are said to be functions, which are one to one and many to one. So one to many is not a function. Both kinds of arrows are used when mapping f from x to y. It's given by the mapping of f, where x maps to y, or x maps to f of x. Since y, if you return to functions, y is just the same as our f of x. Where f of x is a rule for obtaining the image of x under f. We have the rule, or this is our equation in finding y or f of x given a specific value of x. The set of elements in x as the domain, or the set of pre-images, while y as the codomain. So, balikan natin, no? The set of all pre-images are said to be our domain. And the set of all possible images are our codomain. I did not use the term range. And I use a definition, the set of all possible pre-images is said to be the codomain. And the set of all images, yun yung range natin. And the part of the codomain used in the mapping is called the range, or the images. Not all the codomain may be used in the mapping of f. As an example, ito, we have the function f, where z maps to 0, 1, 2, 3, and so on. Or another way, n maps to n square. Ano ibig sabihin nito? Not all the codomain may be used in the mapping of f. As an example, for a function, we have z, no? We have z. Our pre-images is z. And they are mapped to 0, 1, 2, 3, and actually these are your natural numbers. Hindi kasama the integers from -1 to -infinity. -1 to infinity. And then we have n. Our n. Let's say n is an integer. Every integer daw is being mapped to its square. So not all n are used up as our images. Not all n are used up as our images. Ang gagamitin lang nating ranges are the values defined as n squared. Designates, let me go over this. Designates the mapping in which the image of each integer n is n squared. Good. Every integer n is n squared. Let's say 2. 2 is mapped to 4. And we have integer 3 maps to 9. So there were some integers na hindi ginamit as images, like 3, like 5, okay? Like 7. These are not perfect squares. Yun lang yung ibig sabihin. Now, there are two kinds of functions. There were two kinds of functions. One-to-one and on-to. One-to-one and on-to. A one-to-one function may simply be written as one-to-one. One-to-one. So for example, let f be the mapping where x maps to y. The function f of x is one-to-one if f of x sub 1 is equal to f of x sub 2. Then it follows that x sub 1 is equal to x sub 2. In other words, if x sub 1 is not equal to x sub 2, then we can also say that f of x sub 1 is also not equal to f of x sub 2. For example, para mas malinaw. For example, f of x is equal to x squared. It's not one-to-one. Bakit? F of x is equal to x squared is not one-to-one because it did not satisfy our definition. Now we have f of 1. F of 1 is equal to f of negative 1. F of 1 is equal to f of negative 1. Pero using the function, using this function, if we substitute 1 and negative 1 using this rule or using this function where 1 squared is 1, negative 1 squared is 1. Meaning to say, f of 1 is the same as f of negative 1. Pero we clearly see that 1 is not equal to negative 1. Therefore, it is not a function. This is not a one-to-one function. If you have a question, just raise your hand or just try to speak so that I can recognize you. And moreover, we have permutation. A permutation is one good example of one-to-one function. For example, is we have A. It's being defined as the permutation. We have the elements 1, 2, and 3, and their orders are 2, 3, and 1. So, hindi pwedeng magsama sa isang order yung dalawang elements. Okay? Hindi sila pwedeng pagpatungin. The mapping A gives A of 1 is 2. Okay? Or yung element 1 natin is located at 2. Our element 2 is located at 3. Then we have element of 3 is located to 1. Or baliktad. Baliktad ba yun? Or regardless, basta there's a 1-to-1 correspondence or relation or function between the elements of the elements and the order. I should say the elements and the order. So that is 1-to-1, no? Now we have injective mapping. If or let f be a mapping such that distinct elements x sub 1 and x sub 2 of the domain always have distinct images. F of x sub 1 and f of x sub 2, that is x sub 1 is not equivalent to x sub 2, implies that their functions were also not the same, or yung kanila images are not same. Then f is said to be an injective mapping. An injective mapping is simply more technically termed given to one-to-one mapping. One-to-one mapping. So, the same lang daw. Same lang. A one-to-one function that is when mapped, we call that as one-to-one mapping. Or, more technical term, we will be using the injective mapping. Injective mapping. Example. So, given all those definitions, definition ng one-to-one, definition ng domain, the range, and injective mapping, let's try to find out or to show that f of x is equal to 3x minus 2 is 1-to-1 relation. Okay? I mean function pala. Let's try to show that f of x is equal to 3x minus 2 is 1-to-1 function. Or this only means to say that for every value of x, there is a unique value of f of x. For every value of x, there is a unique value of f of x or y. Right. So our solution, since unique yung y's natin, our f of x, therefore, two distinct x's daw, values of x should not or should have different values of f of x. So ito, ang ibig sabihin nun. If we use x sub 1 and x sub 2, their functions must not equal. It's not equal. Then, okay, using the same saan ba? Definition, we have 3x sub 1 minus 2 is equal to 3x sub 2 minus 2. So assuming they were equal. Assuming first they were equal. So by algebra, wait lang. Ang ginagawa naman. We have 3x sub 1 minus 2 plus 2. Saan nanggaling yung plus 2? Ito muna yun, we have 3x sub 1 minus 2 and then 3x sub 2 minus 2. We added 2 both sides of the equation. Both sides of the equation. Now, regardless of that, since same lang, yung inad natin, parang balance lang yung equation natin since they were equal. If we add to the left side, we add to the right side. So, balance pa rin. So, that's why we cancel. Cancel si negative 2 plus 2 and same goes with the other one. Question. Ito kayo yung box natin. Saan po galing si plus 2? We're just try to cancel out the negative 2. Kasi we're trying to see whether x sub 1 and x sub 2 are equivalent. Okay. So, iwan natin si x sub 1 and si x sub 2. So, we have, ayun. So, ulitin ko, assuming na they were equal, assuming this is our assumption, if they were equal, x sub 1 and x sub 2 are also equivalent. Okay? Assuming that their functions are equivalent, therefore x sub 1 and x sub 2 are also equivalent. Yan yung uniqueness. Ibig sabihin, unique yung value ng x sub 1, which is the same as the value of x sub 2. So, where na tayo? Ayan, we canceled out negative 2 plus 2. And later on, we divided 3. Both sides of our equation. So we therefore find out that x sub 1 is equal to x sub 2 for every, or if the functions are equivalent. If the functions are equivalent. Therefore, we can say that f of x being defined as 3x minus 2 is 1 to 1. Question, guys? Nakuha nyo yung definition or yung process natin?
So far, clear naman.
About the others?
Okay lang, sir.
Sige, Dali lang naman eh. And then we have the second example, second function, we have the onto. We have the onto. So meaning to say, if we already finished the one-to-one relation, ibig sabihin si onto could be the many-to-one. The many-to-one function. And then, let the mapping of f be the mapping where x maps to y. If f is to be an onto function, if all y's, an element of y, then there exists x, element of x, such that f of x is equal to y. Now, if all y, element of y, then there exists x, element of x, such that f of x is equal to y. So, ibig sabihin lang daw nito, for every value of y daw, there should be a corresponding pre-image. Okay? I repeat. This line, let me define this line. Okay. F is said to be onto function if all y in element of y, or I can use this as the codomain, no? The codomain, kasi all y's in y. All y's in y, possible images, I mean, images, tama. The possible images, there exists an element of x, an element of x such that f of x is equal to y. Ang ibig sabihin lang nito is that every image daw natin, or every element in y should appear as an image of x, of at least one x. I repeat. All elements in y should appear as an image of at least one, of at least a value of x. A value of x. Sige natin. We can illustrate an onto function as well as a function that is not onto in the following diagram. Okay. This is an example of onto function since every element in y appear as an image of at least one element in x. Okay? Ang reference natin is the elements in y. Elements in y. So we have this onto. F is onto. And when do we say that a function or a mapping is not onto? Let's try to observe the elements of y. Elements in y pala. Elements in y. There is this one element in y that is not an image of a certain element in x. Therefore, this cannot be an onto. This cannot be an onto. Although function pa rin ito. Although this is still a function. Gets?
Yes, sir.
In the second diagram, we can see that there exists an element of y that has no pre-image. For example, for y element of y, there exists no element x in x to form the relation y is equal to f of x. There is an element of y, that's no element of x, corresponding element of x. Then we have the surjective mapping. Okay, this particular map, if we satisfy the definition of an onto function, this can also be termed technically as the map as the surjective mapping. As the surjective mapping. And the image set of mapping f from x to y is the same as the codomain y. The mapping is said to be surjective mapping. If the image set of a mapping f from x to y is the same as the codomain y, sige na. The mapping is said to be surjective. In other words, a mapping is surjective when every element of the codomain is in the image set. The surjective mapping from x to y is also called the mapping of y onto x onto y. X onto y. Example. Wala tayong example. Ito lang example natin. Then we have the bijective mapping. A mapping that is both injective and surjective is said to be bijective. A bijective is said to be a mapping is said to be bijective if we satisfy both onto function and a one-to-one function. One-to-one and onto function. Ulitin natin. Ulitin natin yung definition, no? We say that a function is one-to-one if every element in x has a unique element in y, or corresponds or maps to a unique element in y. That is one-to-one. And we have onto naman, every element in y appears as an image of at least one element in x. Now, if we satisfy both, then the mapping is said to be bijective. For example, a bijection from x into itself is a permutation of x. In other words, permutation is mapping of a set of integers onto the same set of integers. Good. One good example of bijective is the permutation. We have the elements in the order. So every element corresponds to specific order. And same goes. Sa isang order, isa lang element yung pwede natin ilagay doon. So therefore, that is an example of bijective. For example, second example, if f of x is defined as 2 minus x over 1 plus x, where we have to map z sub x to z sub y, is f onto function is f onto function. Okay, yun yung kailangan natin, no? So we know what is involved here. We have the symbol z, and for all we know, z is a set of integers. Because z sub x, the set of integers as the domain, and z sub y, again, set of integers as the codomain. Now, solving for x, we have interchange lang natin, no? Interchange natin. Gawin natin, or isolate natin yung x variable from the given function. So we have y is equal to minus x over 1 plus x, and we're trying to isolate x to one of the sides. To do that, take note, we have here cross multiply lang tayo dito. Okay, cross multiplication, y times 1, the quantity 1 plus x. That's why we have here y plus xy. And 1 times 2 minus x, we have 2 minus x. Then, pagsamahin natin yung mga may variable x. We have xy, so left side natin si negative x. We have positive x. We have 2 minus y. And then, we have a common factor x. We can factor out x. Factoring out x, we'll have x times x plus 1 is equal to 2 minus y. And then dividing both sides by x plus 1 will have the value of x. Have the values of x. We have 2 minus x over y plus 1. Y plus 1. And i-test natin for every value of x ba may corresponding value of y. And vice versa, no? For every values of y ba, there's this value of x. We're trying to see if this is onto. So, kailangan, if this is onto, every element in y should appear as an image of at least one element in x. So kapag 1-to-1 ang reference natin is the elements of x. Okay, the elements of x. Kapag kay onto naman ang reference natin are the elements of y. That's why biniligtad natin yung ating independent variable. So if y is 1,
Sir,
yes, Jason.
may question po ako. Sir, paano po naging 2 minus x to? Yung sa dulo po. Yan po. Yung 2 minus x all over y plus 1.
Tama. This should be y. Sorry. This should be y.
Thank you, sir.
Thank you. See, this is negative y. Yeah, this is 2 minus y over x plus 1. Thank you. Thank you for your observation. As I was saying, since our reference are the elements in y, we also interchange our dependent and independent variable. So this time our independent variable is y. Our dependent variable is x. Now we're trying to see if every y has a corresponding x. Pero we can clearly see that if y is 1, which is an element of our codomain, there exists no x in our domain to form the relation of y is equal to f of x. Thus, f of x is equal to 2 minus x over 1 plus x is not an onto function. It's not an onto function. Nagigets? Hello?
Yes, sir.
For example, if y is equal to x squared, where the mapping of f is defined as z sub x maps to z sub y, or z sub x to z sub y, is f an onto function? So, test natin. Solving for x, again, we will be isolating our x and use this as our dependent variable. So we'll have from here, no, y is equal to x squared. Extract both sides. Extract the square root of both sides of the equation. We'll have square root of y is equal to square root of x squared. And then by properties of radicals, If the index of your radical is the same as the exponent of your radicand, then may iwan lang is yung radicand natin. And our radicand there is x. That's why we have x is equal to the square root of y. And take note, if y is negative 1, there exists no x element of our domain such that f of x is equal to x squared. Kasi hindi din nag-exist yung even root, right? Even root or yung mga radicals natin with even index and the radicand is less than 0. I repeat, hindi nag-exist yung mga radicals natin where n or where index is even and the radicand is negative or less than 0. In this case, if y is negative 1, there's no x. If y is negative 2, there's no x. Or if y is less than 0, there were no x values. There were no corresponding x values. Therefore, y is equal to x squared is not an onto function. It's not an onto function. Okay, next, let's try our fourth example, y is equal to x cubed, where the mapping of f is r sub x to r sub y. Is f an onto function? Is f an onto function? Every element in the codomain ba appears as an image of at least one element in our domain. And then the onto function. So to do that, we have to isolate again. We have to isolate the variable x from one of the sides in the equation. So we have this. Same property. Same property na ginamit natin. We have to extract the cube root. We have to extract the cube root of both sides of the equation. In return, we'll have the cube root of y and then the cube root of x cubed. Same index and exponent. So, ang may iwan lang is the radicand, which is x. And y, cube root of y is also be written as y raised to 1 over 3. Okay, 1 over 3. Show you. Cube. Cube root of y is the same as y is equal to 1 over 3 by properties of radicals. Then, for every y element of the domain, or real numbers, there is always real number x element of the domain such that y is equal to f of x. Thus, y is equal to x cubed is onto function. Meaning to say we don't have restriction here. We don't have restriction here. This function will always be true for whatever values of y, or whatever real number y. Okay? Let me repeat that. This function will always obtain a specific value for any real number y. Therefore, you can say that the function y is equal to x cubed is an onto function. So, by observing our given examples, nagkakaroon lang tayo ng not onto function if we have a radical function or a rational function. In terms of x, no, in terms of x, upon isolating x. Or, actually not, by just observing the given function. at necessarily na i-isolate natin sa x by observing the given function. For example, this one. This is a rational function. Rational function. Then we have this. And then we have the radical function. Yun. Tama yung sinabi ko kanina upon isolating x. Upon isolating x. Upon isolating x, if the function obtained is rational or radical, where index is even, yun. Magiging not onto yung function natin. But if not, then the function is onto. Example tayo. Example number 5, y squared, where the mapping of f is defined as r sub x to r sub plus, or any real number to positive real numbers. Okay? Any real number to positive real numbers. Is f on 2? Is f on 2? Since the range of f is only the set of positive real numbers, then x is equal to square root of y is always defined for any y which are positive real numbers. There exists x such element of r sub x such that y is equal to f of x plus y is equal to x squared and onto function. So ito yung gusto kong sabihin kanina, no? If the index is even and if the radicand is negative, hindi defined yung function natin. Hindi defined yung function. But since very specific yung y natin, now we only to use positive real numbers for y. Positive real numbers for y. Therefore, defined. If magiging defined yung function natin. Kasi mayroon tayong specific condition for the values of y. Okay? We have a specific condition for the values of y. Question? Silence means none, no? Silence means none. We have inverse images. Let f be mapping from x to y. If y is an element of y, then the inverse image of element of y denoted by f raised to negative 1 of y is a set of all x, element of x such that f of x is equal to y. Then the inverse image of element of y denoted by f of negative 1 y is a set of all x such element of x such that f of x is equal to y. Okay, siguro mas maintindihan natin to with examples. Consider the mapping of f where x maps to y, where the elements of x are 1, 2, 3, 4, elements of y are a, b, c, d. Now, the definition of f are f of 1. F of 1 is a, or 1 maps to a, b maps to 2, 3 maps to c, 4 maps to d. 4 maps to d. Tingnan natin. F of their inverses is said to be the other way around. A maps to 1, and then we have A maps to 2, then ay, ano ba ito? natin discussion. We know that ABCD is called the codomain. 1, 2, 3, 4, 5, 6. Wala ba siyang discussion? Ayun, ito. The inverse images of elements y are as follows. The inverses of f of negative 1a is 1 and 2. 1 and 2. Paano siya nakuha? Paano nakuha? We have f of 1. Paano kaya? Define f by f of 1 is equal to a. F of b is equal to 2. F of a is f of 1 is a. F of b is equal to 2. F of 3 is equal to c. F of 4 is equal to d. Lang. Is this related to this map? Related ba siya sa map na to? I don't think so kasi ito. Siguro meron akong typo error dito. F of b is equal to 2. Where in our given, we can clearly see that p here is not an image. B here is not an image. Tingnan ko lang, verify ko lang sa hindi naman akong nakopya. Inverses. Yeah, that should be A. F of 2 must be A. Yeah. That should be F of 2. Be A. Take note na, iba yung nakopya ko dito. Yeah, tama. Tama, Edward. That should be F of 2 is equal to A. Kaya nalito rin ako. So, ulitin natin. F of 1 is A. Okay, F of 2 is A. F of 3 is C. And F of 4 is D. So, this time, gawin natin. Reference si elements in Y. Or elements in Y. Or baliktarin lang natin yung mapping natin. If 1 maps to A, therefore, A maps to 1. Okay? That's the inverse. As well, A maps to 2. C maps to 3. D maps to 4. These are their inverses. Okay. So, inverse of A, we have 1 and 2. Inverse of C, we have 3. Inverse of D, we have 4. And ayun. F is not 1 to 1. Of course, it does not satisfy our condition ng 1 to 1. Kasi 1 to 1 kasi in reference to the inverse ba to? Verify ko lang ako. Reference sa inverse, hindi siya 1 to 1. F is not 1 to 1 since F of 1 is equal to F of 2. Ayan. F of 1 is equal to F of 2, which is equivalent to A. But 1 and 2 are not equivalent. F is not on 2 since there exists an element of Y that has no pre-image. So either no, this is not 1 to 1 at the same time. This is not 1 to many. 1 to many, not on 2. Yeah. Yun, natapos na. That ends our discussion kay functions.